Let's take a look at a nonlinear modeling situation, in particular an exponential model. So let's talk about the shape of an exponential model to begin with. And the shape of an exponential model has this behavior that as time goes on, it grows faster and faster. Grows faster and faster. Okay? So if you were to look at a picture of that, it might look something like this. It's speeding up as time goes on. The equation, or let's say the function for an exponential model has a number to a variable power. Has a number raised to a variable power, okay? And so maybe like y equals 2 to the x. That's an exponential function, a number raised to the x power. All right, so let's take a look at an example of a real-life scenario that might exhibit this sort of behavior, and then we'll talk about an equation for that behavior and specific values that we might plug in to work with that function. All right, so let's see an example. So an example here might be how does blood alcohol content, BAC, blood alcohol content, how does it affect your crash risk when driving? Okay? So if you imagine what the relationship might look like on a graph, you've got your blood alcohol content, and over here you've got your crash risk. We'll talk about how to measure crash risk maybe in a minute, but the idea is as your blood alcohol content goes up, your crash risk grows really rapidly. So a scatter plot might look something like this. Starts out kind of slow, but then as time goes on, the risk grows really, really quickly. And so if you were to look at a curve or a graph that models this behavior, it might look something like that exponential curve we talked about before. Okay? And so you could use a graphing device to come up with a model for this curve, an equation for this curve. And if you wanted to, you'd use something maybe called exp for exponential, reg for regression. Okay? So let's say that I've already done that. I've taken some specific data points that relate BAC to crash risk, and I've plugged them in to some graphing device into this exponential regression function, and I've gotten the following equation. Y equals, and because it's exponential, it's got to have a number to a power. So it's going to be y equals a times b to the x. So I need to know what a and b are for this particular curve. So let's say, I've got them written out here, let's say that a is 0.58304,829, and that B is 22,072,021,300. Okay? So we have our model. We have our model now that our graphing device gives us when we plug in the data to the exponential regression feature of the calculator. This is our model. And so now what we can do is we can use this model to answer questions about this relationship. So let's talk more about what the crash risk means. So when we say crash risk, in this particular case, what it means is how many more times likely you are to crash than if you had 0 blood alcohol content. So if you plug in a blood alcohol content into this function, and it outputs 2, then that means that person is twice as likely to crash as if they twice as likely to crash than if they had a 0 blood alcohol content. Okay, so we'll explore that more as we go on. So let's use this model to answer questions. And what I'm going to do now is I'm going to rewrite our function. Instead of a times b to the x, I'm going to rewrite it using this a and this b. So if I were to do that, that would turn into 0.5830489, yep, times this number, 22072021300, that number to the x power. So y equals this. Let's rewrite it that way. Y equals that. That's our model, okay? And so now I can erase this. If I were writing it on paper, I'd probably write it like that. Okay, so now we can ask the question, what is the crash risk for someone with a BAC of 0.08? A BAC of 0.08. And so all we're going to do to figure that out is understand what a BAC is in this diagram. The blood alcohol content is your X value and the crash risk is your Y value. So when we say a BAC of 0.08, that means X equals 0.08, and we're asking for the crash risk, so we're trying to calculate Y, okay? And we know how to calculate Y. We use this equation. So all I'm going to do is take and plug this X value of 0.08 in for my exponent right there. Okay, so I'm going to grab my calculator and go ahead and do that. So I've got 0.5830489 times 22072021300 to the 0.08 power. And it looks like, in that case, I get approximately 3.92. Now what that means is someone with a blood alcohol content of 0.08 is almost 4 times more likely to crash than someone with a 0 blood alcohol content. Okay? Let's kind of see how this plays out if we increase the blood alcohol content. What if someone's blood alcohol content were 0.16? What if it was twice as much? If it were 0.16, now I would plug in 0.16 for X and recalculate my crash risk, my Y value. Okay, so since I've already typed this in once, I'm not going to retype it all. I'm going to hit my up arrow to go back to that formula, and I'm going to change the 0.08 that I had here to a 0.16. And it looks like in that case, we get approximately 26.3. So if you look at that, the blood alcohol content doubled, which was at 0.08, remember, it was about 4 times more likely to crash. At a double blood alcohol content of 0.16, now you're up to 26 times more likely to crash than if you had 0 alcohol in your blood. So you can see this model does grow pretty rapidly, okay? And that's a great example of an exponential growth model.